We're very excited to have you all here tonight. So thank you so much for coming out. We really appreciate this. We've been trying to do some client events here and there. We don't have any regular system for this, but when we come with a great speaker, we take advantage of that and do an event. So some of you, I've seen faces before in some of these events. So thank you again for coming. Really appreciate it. We hope you have a great time. This is a very interesting topic. As you know, at Wealthstream, we work on a lot of technical elements, investments, taxes, insurance, estate planning. But when we're doing that, we're always thinking of the bigger picture and how it relates to your life, and what's important to you, the how and the why, all those kinds of elements. This presentation sort of ties into that and on our overall mission of helping clients live their best lives. So in order to live your best life, obviously your financial matters are important, but so is health and paying attention to your longevity and those types of elements. So we're hoping that you'll learn tonight about some of those things and about some of the things that are on the forefront to help you live longer lives. So once again, really appreciate you all being here. I'm just going to read Dr./Professor Rothman's bio real quick, just 2 or 3 lines, because I want you to know a little bit. And that is that he is a distinguished professor and the Wilcox Family Chair in Biotechnology. He's also the director of the Biomolecular Science and Engineering program at University of California, Santa Barbara. And we're super excited about being here because he's also the founder and director of the Center for Aging and Longevity Studies. So clearly a much longer, impressive bio and a very interesting life that Dr. Rothman has had. But without further ado, take it away.
I'm going through okay. There, is that good? Okay. Well, I really have to express deep gratitude to Michael and to Wealthstream for the invitation. It's absolutely a delight to be here, to be in one of the really great cities. Some would argue the greatest city on earth, and I will not take exception to that. I lived in Paris. I love this city, and these are my peeps, frankly. My dad grew up here. My mother grew up in Greenwich. This is sort of, and I almost grew up here. I spent 2 years, the first 2 years of my life, so I don't remember it. I just love coming back to New York whenever I have the opportunity, and it is a delight to be here. I feel like one of you all. You don't say you all. So anyway, thanks so much for taking the time to hear what I have to say today. So before I get started, I think there are attorneys out there. Are there any attorneys? A couple. Okay. So because of that, I need to make my disclosures, of course. So my disclosures are as follows. First of all, I do save. Secondly, I do invest. And the third is I don't know anything about financial or estate planning. So if you want to find out about that, talk to the expert, because I don't know a thing about it. But what I do know is a little bit about aging and longevity, and that's why I founded the Center for Aging and Longevity Studies about 4 years ago. That center is a really exciting growth. It's in a very exciting growth phase right now. We are probably one of the most interdisciplinary centers for aging and longevity in the U.S., not in the world. By which I mean we span a large range of disciplines. We draw faculty and research groups from 17 different academic departments. That really go quite a way. So those departments are at the core in biomedicine, but also engineering, computer science, psychology, social sciences, and even the humanities and fine arts. We have 37 research groups right now with over 350 researchers affiliated with those groups, and the center is growing constantly. And if you're interested in learning more about this center, what we're up to, if you have any questions about any aspect of aging and longevity studies at the research level particularly, please drop me an email. You can just Google my name. I also, let's see, right back here, the center is very easy to find. If you just Google longevity and UCSB for Santa Barbara, it'll pop right up. And I'll tell you more about some things that I think we're creating that'll be useful to all of you, not just to researchers for sure. And this covers the sort of the span, not only, as I was saying, not only the science of aging and longevity, but also the aspects of society. And if I have time, I'll talk about that a little bit today as well. Okay, so what are we about here? Wealthstream Advisors, and I know many of you are clients. that deals with the intersection, of course, between capital and time. And the nice thing about the intersection of capital and time is it grows. The capital grows with time, of course. And that's really what financial planning is all about. Wealth grows with time, but life does not. As you well know, life shrinks with time. And you cannot grow the time you have on this planet by hard work or investments. You're given a certain amount, and that's what it's going to be. Of course, you can do things to optimize how long you live, and we'll talk about that a bit. But an hour spent in your life is gone forever. You're never going to get it back. And I apologize if you do not enjoy this hour. I've stolen an hour of your life, and somehow I'll try to pay it back to you, please. Okay, so one of the things, the reason that I've been speaking at groups like this is that, of course, the investment horizon is a very important part of financial planning, and you can increase your wealth through the appropriate financial planning, especially if the horizon's farther out. But what if I told you that you might actually be able to do that in life as well? What if I could give you more life, right? So I'm not promising anything, but I think that the promise is very much there. So let me leave you start you with the first key message, which is that I feel pretty strongly that your current investment time horizons ain't going to work pretty soon. I'm not going to put a time limit on that, but I think things are going to change. So our goal in this science, in the area that I do research in longevity science, and I'll tell you about some of the science that's done, our goal is to ruin your plans for investment horizons. That's really where we're trying to go, and I'll explain. Well, it's kind of obvious what I'm saying there. The horizon, if it's going to be farther out, we're going to be ruining your plans. The actuarial tables will need to be changed. Of course, they're changing all the time. They're going to need to be changed more. I will mention, since I mentioned actuarial science, because of my first contact with the community of financial planners, I went to a meeting and gave a talk in Austin, because of that meeting, we actually added on another faculty member. We're going to get more who work on actuarial science. So we really cover the gamut of things that impinge aging and longevity throughout society. All right, so there was a billboard going around. This may have been true in this area some years ago. This is from Prudential. The first person to live to 150 is alive today. Rather provocative statement. So the question is this hype by an insurance company, or is this based in reality? And what I would say is the newest science that's happened, and the reason I decided to start this center, which is really blowing open, it's coming fast and furious, would argue that this may not be hype. I have a 2.5-year-old granddaughter. It would not surprise me if people in her age group, some could live to 150, and I'm going to justify that. And it may be, in fact, people who are older than that as well. We'll see. Okay. So our goal in this science is not to extend longevity per se. We have zero interest, and I really want to emphasize this because there's often confusion about this period. We have no interest in extending the period of life after people are in a miserable state, after the age, the deprivations of advanced age are hitting people. We don't want to extend, we don't want to keep people on life support for long. That's not what we're about. Our goal is to extend the period of health. So as you are all aware, over our lives, we have a period of health. And then, unfortunately, starting in the 50s and 60s and then climbing up steeply after that, a huge range of age-related diseases kick in. And that's what you're seeing in this. Cancer, heart disease, stroke, Alzheimer's and other neurodegenerative diseases, obesity, diabetes, susceptibility to COVID, osteoporosis, et cetera, et cetera. So something's happening in our first many decades, right? Something's happening there to set this off. And what our goal is to do is to get at the root cause of all these diseases. Instead of treating each one of these individually, which is exactly what physicians do, and it's also what the National Institutes of Health that funds research does, they focus on each one of these. Instead of doing that, what we're trying to do is get at the root cause. What precipitates this upswing in all these diseases? If we could get at the root cause through some kind of preventative medicine, then we could actually forestall the onset of all these diseases simultaneously. With a single treatment, in theory, we could treat all these diseases simultaneously, and that is prevent all these, or at least delay them. There's also, so that's an important, obviously, medical aspect to this. There's also a very important economic aspect that you're probably quite aware of, and that is that the medical costs in our society, which are really high in the U.S., really start soaring after age about 65. And in fact, the cost for people from 65 and over is about 3 times more in healthcare costs than the working group of people and working people, and 5 times more than it is for children. So it's disproportionate to the older people. The reason is, for example, that chart that I just showed, because age-related disease is extremely common, takes off at a certain age. And by 2031, health costs are going to amount to about 20% of the gross domestic product of the United States. 20%. One out of every $5 is going to be just devoted to healthcare. So if we can reduce this stuff, which is the disproportionate cost part, then we can greatly diminish healthcare costs and stimulate the economy. Okay, so this sort of summarizes what we choose to do, and that is we want to stretch out the period of health span. So we can think of a normal lifespan being a period of health, long period of health, and then age-related disease kicking in, age-related decline, all sorts of nasty things that happen. And our goal, again, is not necessarily extend the lifespan, although that will happen to some extent, but instead to stretch that period of optimal longevity, the health span period. We just want to stretch health span. We want to make people stay young and vibrant longer. If we can achieve it this way, we can also hope to achieve what's called compression of morbidity. Here's a longer period of morbidity. We can hope that we stay really young and healthy, and then suddenly, bang, we're gone, right? I mean, that would be an ideal thing. And so our goal is to basically try to make us all more youthful as we age. Okay, so how can you do that? How do you do that? And does this even, does science support this at all? The answer is yes. So all of us have a clock, and it's just ticking away. It's the aging clock, I'll call it, right? Things are happening progressively with time. We are looking at the intersection of time and biology, and there it goes. It's winding away, and you know what happens over time. Our goal in this science is simply to do the following, just to slow the clock. If we can slow down the rate of aging, then we can extend the period of health span, and we can essentially intervene in all of those age-related diseases simultaneously, and of course, extend the youthful vigor of everyone who is lucky enough to experience the interventions, if they're possible. All right, so let me first say, I'm going to talk to you the science mostly, but let me first say that you probably are already familiar with lots of things you can do to intervene in aging and slow the aging clock. And I'll just touch on some of the major ones. There are more, and you can ask me in question session, what about this or that? And I can't cover it all. I want to go through this fairly quickly. But of course, exercise and the proper diet and the amount you eat together are going to contribute to a longer life expectancy. Those two together act together to extend life by at least 7 years. Okay, so there you get 7 years just by eating right and exercising. There's another thing that can be done, and I'm not recommending it, although it does seem to work. It's kind of depressing. Often I give these talks at a dinner, and I hate to bring this up. It's painful. But in fact, keeping a modest weight is good, of course. That helps with like cardiovascular health and so forth. But there's a different impact of ramping back calories even further. This was discovered when mice were found when they were starved about 100 years ago. Starved mice actually live longer rather than shorter, what the scientists thought they'd see. And now every organism that's been looked at, when you cut back on the number of calories, particularly if you bring the organism close to the edge of starvation, they live substantially longer, and they stay healthy and youthful longer. It's quite striking. This was true in every organism except humans until recently, and now recently, the bad news, or good news if you want, is it works the same way in humans. So a study of a large number of individuals, a cohort of individuals had a normal intake, that's that upper blue line, or a reduced intake of calories by only 25%. That's the good news. They just, so you have that steak in front of you, throw away 25% of that. And the rate of aging, that's what's being looked at. The rate of aging is dropping down in the first month, and first year, and then the second year. It's quite striking effect. It works in humans. Now, actually, I have to say that some people interpret this a different way. They say, if you're living at the edge of starvation, it's not really true that life goes longer. It just really feels like it. But actually doesn't work. Okay, there's another thing you may have heard of, the blue zones. There's a Netflix series on the blue zones. You can look this up. This is 5 areas on the planet spread across the globe. One is in California, not very far from me, where people live there are a disproportionate number of sensitive areas and super sensitive areas, people who live over 100. And there are certain characteristics of those. I won't go through them, but it has to do with diet, exercise, and also psychosocial aspects. Sense of community, sense of purpose. And these are very disparate cultures: Japan, Greece, Italy, Costa Rica, and the U.S. Very different cultures, very different genetic compositions, but they have those things in common, and it seems to contribute to extended lifespan. So I'd encourage you to look up the blue zones if you're curious about that, and you could choose to live a blue zone type life. Another very important one is sleep. I think everybody knows this. When I was growing up, especially in science, it was totally macho to get as little sleep as you could and brag about it. All we were doing was shortening our lifespan. A good full night's sleep every night is going to increase your life expectancy. There's no question about that. In fact, in men, it extends, in the studies that have been done, it extends lifespan by 5 years in men. 5 years getting good night's sleep versus not. That's, 5 years is a good one time. You can have a lot of time, a lot of fun being with your family, or playing with your children, or going hiking, or whatever you want to do. Okay. Now, there's another thing that a lot of people do, and that is take supplements. And this is a multi-billion, huge industry, right? The supplements industry. Now, I want to say something about this. The science behind nearly all supplements that are out there is either a little thin or non-existent. That's a controversial statement, but there is some truth to that. And there's been a long history of this. This emperor of China, who built the Great Wall of China and also the terracotta soldier, maybe some of you have seen those things, 1,000 of them. That guy was fixated on wanting to live longer, and he had advisors who helped him with that. They made various kinds of potions, including essentially tea made from mercury. It didn't work too well for him, and he didn't live nearly as long as he would have liked, as you can see. And actually, this problem persists today. This is a case that just came out in June. 80 people in Japan died from a supplement that was recommended to be taken. It's supposed to extend their lifespan. So you have to be very careful about this, obviously. The supplements are not regulated in the same way that pharmaceuticals are by the FDA. And the studies generally don't support their use at the same level that a newly developed drug would be. We in the Center for Aging and Longevity Studies at UC Santa Barbara are developing, thanks to a gift from a generous donor, we are developing a public clearinghouse for reliable science-based information, evidence-based information on which interventions appear to be effective, which might be ineffective or might not be. You don't know, but we'll present sort of the relative, our best guess based on the scientific literature, or which might actually be actively harmful, either no effect or might be harmful. We're going to be launching that over the next year, so keep your eye out for that. By the way, if anybody wants to get on our mailing list, we do not spam people. We send out an email every few months, but we will be updating you on that. We'll have a press release, but if you're interested, that'll be free to the public, and it is there for your benefit only. Okay, there are supplements that do help. What I will say is this just came out in Consumer Reports, for example, 7 anti-aging supplements. They are, if you look at this list, do any of these shock you? You've heard about all these. There's nothing new here. We've known about most of this stuff for 50 years or more. I mean, vitamin B12, vitamin D, 70 years or whatever. And none of these truly slow down the aging clock. They can treat various elements related to aging, but they are not truly anti-aging, in my opinion, because they don't slow the aging clock. But there is one that must. But I am not recommending this, okay? So the attorneys don't sue me, okay? I'm not recommending this. I'm just putting it out there. And that is one called taurine. Taurine is a natural substance that you have lots of in your body. You eat lots of it. And it turns out as we age, sort of following that chart that I showed you, the onset of age-related disease here, with this, roughly the same onset, taurine levels drop in our bodies. They actually go down. So I would have had much lower taurine levels. I'll tell you what I mean by that. And that's found in every creature that was looked at. Every creature, including humans, taurine levels drop. So these investigators, this came out last year, and this certainly changed my thinking about this particular supplement anyways. They brought those levels back up in these experimental animals and found that if they restored the taurine levels, what they found is the lifespan increased. So here, for example, this is a mouse, for example. This dotted line is how many are alive at a certain time. This is time, so number of years this way, and they're dying off over time. And notice this curve is being shifted that way. That means the animals are all living longer on this the supplement. When you look at that, those animals, you find that their health span is increased. All of these various markers of aging, brain function, for example, that's important. They're not having dementia as early and so forth. Gut function, et cetera. All those things, they were all improved simultaneously just by taking a very simple supplement that you can buy almost anywhere, taurine. It's also in Red Bull, by the way, hence Red Bull, taurine, Taurus. Oh, that's where Red Bull, that's where the name came from. I am not recommending it. I do take it. As soon as that paper came out, I thought, this looks good because the risk, I think, is extremely low. It's something we had a ton of in our diet anyway, and we make a ton of it anyway. And the benefit, we don't know because it hasn't been validated in humans yet, but it works in every organism that's been looked at so far. Seems like it's worth a try, in my opinion. Okay, so this is sort of a quick summary of the things that you could do now. Some of the things. This is not comprehensive, and please, if you take that photo, please do not claim that these numbers are right. Okay, because I made up some of these, sort of. These are my best guesses, but they're not validated. A lot of the stuff is not validated in humans, with the question marks particularly. Well, we know exercise and healthy weight, as I said, at least 7 years. That's good. That's strongly supported by science. Not smoking, 10 years. Smoking can take 10 years or more off your life. Of course, it can take more if you get early lung cancer. Sleep, 5 years. That's well validated in a large-scale study for males. 2 years for women. Blue zone lifestyle. This is I'm kind of making up, but it could be 10 years or more. Not being a heavy drinker. This is really sad for me. Not being a drinker at all. The best thing is not to drink anything. I was a professional winemaker early on in my career before I got my PhD. You know, I love wine, but I mean, ideally, it's best not to have any. Now, I'm not going to do that. So, and quality of life matters. I mean, a wild guess, you know, depending on how much you're drinking, 3 to 10 or more years, that if you're not a heavy drinker, you're going to gain. Caloric restriction, this has not been, the exact number in humans hasn't been determined. My guess is 5 years or more. And taurine, total guess based on animal studies, 3 years to goodness knows how much. We don't know. Okay, that's why I didn't want you to take these numbers. But these are all things you could do right now. Okay, but this stuff is the tip of the iceberg because the rapidly advancing science in this field of aging and longevity, technology and science, is going to get way out in front of all these other things. That is to say, the things I'm going to tell you about promise to really potentially push health span extension and lifespan extension very dramatically. And I say that because some really remarkable discoveries made in the last 10 years, and even in the last 2 years, even in the last year, really startling, mind-blowing discoveries for me, I think, as a scientist. And that is based on the really intense amount of research that's going into this and some really big breakthroughs. This was today. I look it up every time I do a talk. I update it. There have been 691,120 publications that have aging or longevity in them on the National Library of Medicine website. That goes up by roughly 100 a day. So huge amount of activity in this area around the world, of course. I've read every one and continue to read every one, of course. I got to go home tonight and read the 150 that come out today. Obviously, this is not true. And so what has this led to? It's led to some pretty striking breakthroughs. So let me start in terms of thinking about these breakthroughs with maybe something that in a way is kind of intuitive. And that is that the biggest effect on our longevity is not all those things I've talked about, but our genetic makeup. Our genes have the biggest effect on it. So you take these two creatures, right? These two creatures had quite different lifespans. This thing, 12 to 15 years. The other creature there was probably roughly the age of my granddaughter. 80 years or more. Her life expectancy probably even more. I think it's going to be a lot more once as the science proceeds. Why do they also have wildly different lifespans? It's the same reason that they're different species. Their genes program that. They have different genomes. Their DNA is different. And in that DNA is the program for the rate at which the aging clock proceeds. Okay, let me take this one step further by looking at evolution. So evolution teaches us a lot about this. If we look at a range of creatures, humans, life expectancy around 80 years, that's going up. The little worms up there, I'll say more about, they live only 3 weeks. The shortest lived creature, the dainty mayfly, lives about 4 hours. When it becomes an adult, this 4 hours is gone. That's the females. The males have a much longer life. They live about a day and a half. These little worms live 3 weeks. I'll tell you about these worms, why they're important. Rats, a couple of years, although there's a weird rat, the naked mole rat, that lives 30 years. The only difference between those two creatures is the major difference is that their genes are different. Their genomes are different. In fact, it has been possible to take genes out of these guys and put them in those guys and change how long they live. Now, not as much as 30 years yet, but someday I think that will be possible. Okay, humans, of course, 80 years. We know how far it can go because of this woman, Jean Calment, who passed away in 1997 at age 122 years old. Looked pretty good at 40. At 80, she's still looking pretty good, I think. 121, there she is. And a remarkable thing about her, in fact, she was a smoker and a drinker. But she did quit smoking. She quit smoking at 117. So, that was not there she is when the day she quit, or close to the day she quit. Still kept drinking. Okay, so that's sort of the upper limit for humans. Now, we keep going down the line, and we have not hit the ceiling, right? There are two creatures that are sort of like us that live even longer. The bowhead whale is a mammal like us. They can live 200 years, and what I call the bowhead whale is Jefferson because there are bowhead whales swimming around on the planet today that were alive when Jefferson was around. Okay? Same mammal. The Greenland shark, so these guys were mammals. These guys are vertebrates like us. They have the skeleton like we do. Cartilaginous, a little different, but still, they're not that far away from us. Greenland shark can live half a millennium. That's a long time for most trees, right? And I call those guys Magellan because there are Greenland sharks swimming around on the planet today that could have swum right under Magellan's ship back when he was going around the seas. Pretty remarkable. So that means that, and I'll say one other thing, that the Greenland shark, this one, lives 500 years. Its genome is just published in the New York Times in September. The genome has been decoded, right, for this guy. So we can learn a lot from the genome of an animal that lives 500 years. We could maybe take genes out of that and think about using them in ways that can extend human lifespan. So what can we conclude from all this? One thing we can conclude is that this huge range in age that we see, the dramatic difference from days to near fractions of a millennium, are attributable to gene changes. The course of evolution has resulted in many, many gene changes along the way. That's what makes these creatures different, and that led to changes in their aging clock. So that you can get 500 years or you can get a few days. 2, that we have some room here because our life expectancy is in the middle here. We got some room, so we haven't used it up yet. We would like to think we may be able to push it further. And 3, if you were a scientist and you didn't know you were going to live to 500 years, you live normal lifespan, and you wanted to study interventions that extended the lifespan. You wanted to do experiments to say, how long does it extend the lifespan of an animal? Which creature would you want to select? You want to do the experiment and see, oh, how much longer did they live? The whale?
So you want to wait from 500 years to 800 years. Is that what you mean? The worm, right there.
Okay? Thing lives only 3 weeks. A graduate student can do experiment after experiment after experiment that affects their lifespan. And that exactly is how this was discovered, that single gene changes greatly extend the lifespan of an animal. My colleague in the field working on these little worms, so these are little worms called C. elegans. Most of you probably even have not heard of these little guys, but they've been a very powerful animal, laboratory animal, for studying lots of different aspects of biomedical science. There was, until 3 weeks ago, 8 Nobel Prizes already won by colleagues in my field, in the C. elegans field, because of their important contribution to biomedical science, but 2 more just popped up in the last 3 weeks. My colleagues, Victor Ambrose and Jerry Rokin, also, I knew it was coming, also shared a Nobel Prize just the last 3 weeks, working on these little creatures and making really profound discoveries. And they have been a tremendously important contributor to our understanding of aging and longevity, because they don't live that long, and so you can extend their lifespan and see it right in front of you. One of my colleagues, Cynthia Kenyon, many years ago, found that a single gene change, one letter in the genome of these animals, can extend lifespan by as much as tenfold. So they have about 100 million letters in their genome, and you can think of them as letters. They're called nucleotides. Some of you may remember from high school. 100 million of those, you change 1 out of 100 million, and these creatures can live this long instead of that long, and they stay young that long also. Their period of youth extends equally. Okay, that's great, but that's worms, so who cares? Well, the reason you should care is that the human version of the gene that does that is also modified. It's also different. There's a gene change in many centenarians, in people who live to be 100. They show that same gene change. Okay? And I won the prize as Adele went on. So, okay, so it's relative to humans. Now, so what do you do with the gene changes? I'll say more about that in a few minutes. But one of the things that a gene change like that can do is it can point you to a possible drug that has the same effect. And that has worked out. So in fact, in these little worms, there are now hundreds of gene changes that extend their lifespan. And that points to many different potential drugs, because a gene change can be equated to a particular compound, a drug, that has the same effect as the gene change. And that's been used. And that did work specifically in this case. So there are a number of drug leads now that seem to extend health span and lifespan. And those drugs came from the studies I'm talking about. One of the most promising ones is called rapamycin. Was found in Easter Island, which is called Rapa Nui, hence the name rapamycin. The thing about this drug is that it is repurposed. That is to say, rapamycin, any physicians in the room? Okay, rapamycin is used as an immune suppressant. That is to say, when patients get organ transplants, they are often put on rapamycin to prevent them rejecting the organ. So they've been validated. It's not only FDA approved for a long time, it's been validated in humans for a long time, so we know what the consequences of using it are. So repurposed drugs are great, especially for somebody my age, because I'm kind of getting anxious here. Like, give me something. And if rapamycin, because of the studies in those animals, increases the lifespan of all these creatures, all of them, from yeast, believe it or not, all the way to mice. Now, any drug that increases lifespan across such a huge range of creatures, I think, is very likely to have an effect on humans, because we're essentially mice when it comes to looking at that range of this. And in fact, it's in clinical trials right now. Phase 2 clinical trials, if I have it right, is going to be completed in December. That will give us a pretty good measure for whether it worked on older individuals that have been taking it. A lot of people are taking this now. Physicians can prescribe it to themselves right now. I haven't started to do it yet, but I'm getting ready to see how these studies come. Because the thing is repurposed. We already know about it. And in fact, again, if you read the New York Times, you might have seen this article, rapamycin just came out. This is September. Just came out as it's kind of in the popular gestalt now. People are certainly aware of it as a potential anti-aging pill. Right now, there are over 100 clinical trials going on in humans for age extent for anti-aging interventions or things that extend the period of health span. That's happening right now, and that's growing like crazy, of course, as you can imagine. Now, one of the problems with all these studies is if you want to see if a drug, for example, extended human lifespan, what are you going to do? Wait, oh, you were supposed to die at 89, you lived to 90. You have to do a huge population study. You got to wait a long time, right? So what if we had a way to instead monitor the rate at which the aging clock is going? And that's been a huge breakthrough in the field, enormous breakthrough. We have a pretty accurate, many accurate ways now of measuring how fast we're aging. And I gave an example of that when I talked about calorie restriction. That was what those graphs were about. Now, sorry, this gets into the weeds for just a second, but this comes down to the fact that our DNA, our genome, gets little extra pieces put onto it. Now, these pieces, that is to say, our DNA is just a whole bunch of letters. That's all it is. A whole bunch of letters that spells out the word that is, or the whole sentence that is an organism. But in addition to those letters, these little pieces are put on. They're called methyl groups. And those things are like in languages, diacritics. I like the characteristic of diacritics. The diacritic are all these gizmos that go on letters, not in English, but in other languages. If you study those languages, you will have encountered these for sure. So these are diacritics on DNA, all these little extra things. And the thing about that is that many of those they're all over the whole genome. So there's a huge number of these things, and many of them change with age. So a computer and statistical methods can be used to say, okay, if we know somebody has an affected biological age of so-and-so, what are their diacritics at that point? And if changes, so how quickly are they aging? So this has proven to be a very powerful way of measuring the age of an individual, a biological age, not the chronological age. I came back from my 50th high school reunion last October, a year ago now, and I saw people there who looked 50 years old, even though we're all supposed to be around 67 or whatever, 68. And there were people there who looked 90, right? All the same age, born the same year. They had very different biological clocks or really high quality plastic surgeons, or both, probably both. But the rate at which we age is different between us. And the cool thing about this biological clock now, or this aging clock, is that you can change it. So I don't kind of really want to know what my biological age is right now. You said that gives you a baseline. I want to see what I can do to slow it down. And so, in fact, if you do things, and this has been shown with this clock, if you do things that are good for you, food and exercise, you can slow down. That's what this age deceleration is. You can slow down the aging clock. And the things that are bad for you, and some of these things are shown up here. Stress, for example, is a big one. Infections, neurodegenerative diseases, etc., can speed up the aging clock. Now, this also means that you can monitor the rate of aging with an intervention. Like if you take taurine over a while, you can say, oh, well, did this slow down my aging clock or not? These studies, I'm sure, are just beginning right now. The taurine thing is brand new, just from last year. But you can yourself do the experiment on yourself and say, okay, how much does it slow down? Because you can send out a cheek sample or a blood sample, and you can get your effective biological age and then follow it over time and say, oh, this month I was particularly good, or this 6 months, gee, how did it affect me? And in fact, we know with the caloric restriction thing, it worked. That's how that was measured. We don't have it yet, but we will have devices, just like my Apple Watch, right? Where you can kind of look and say, oh, here's how much I aged this year, or whatever. So that's going to be really powerful. Another thing that is tremendously powerful is gene therapy. We can go inside the genomes of organisms, we can get to their DNA and actually make changes in the DNA. You may have heard of CRISPR, for example. The discoverer of CRISPR just gave a talk in Santa Barbara. And she got a Nobel Prize for this discovery. So we can actually change DNA, and that's potential gene therapy. So here's one thing. Yeah. So gene therapy works in mice. You can slow down aging, but you can go even further than that. And the basis for this is that we know there are two kinds of cells that we carry around. There are those that just age, ticking along forward. That's what we're used to. There are also cells that do the opposite. There are cells that de-age. Those are the cells that give rise to the next generation. A baby is not born old, it's born young. The cells that had all this stuff from their parents that accumulated over time got rid of all that stuff, all the problems that come with aging, the sperm and egg got together and it was refreshed. So the aging clock wound backwards. And in fact, through gene modifications, you can actually reach the possibility of backing up aging. This is what we call the Benjamin Button effect from the F. Scott Fitzgerald novella and the movie you may have seen. This actually works. So I'll just flash a few quick ones on here. My last study is this stuff. We didn't do the study. Mitochondria, some of you may have heard of these things. They're inside our cells. They're the powerhouse of the cell. These experimenters, and they're associated with aging. Mitochondria are very heavily associated with aging. So what they did is they messed up the mitochondria in ways that would happen in aging using a genetic trick, so gene therapy kind of thing, and they got mice that looked like that. And then when they restored mitochondria back to being normal, so here's the bad mitochondria, they take these same mice and say, oh, let's make them better again. Let's make the mitochondria better. And the mice have de-aged. They look young again. Pretty remarkable. And I can go on with this. I'll just quickly say this one is extremely exciting. This is a set of proteins. Another Nobel Prize was won for this by a guy named Yamanaka. These are Yamanaka factors, as they're called. They were discovered in a different context, in allowing cells to turn into one kind to another. So you can turn a heart into a liver or whatever. But it was found that, in fact, if you give mice these factors, you turn them on using genetic modification. They turn them off, turn them off, and you keep going around. What happens is older mice get younger. Many of the signs of aging are reversed. This guy didn't get it. That guy the same age did get it. Okay? So this is pretty remarkable. One other thing, a lot of mouse pictures here. We accumulate what are called senescent cells. Senescent cells are also called zombie cells. As we get older, I'm filled with these things. People who are my age or older are filled with these things. And those cells, unfortunately, they don't do anything for us. All they do is they make us age. They actually secrete, they send out stuff that makes us age quicker. The way we can just get rid of those, just kill them off. In fact, it works. So in this case, this mouse got the senescent cells wiped out. This one didn't. Look at the difference. I mean, you could tell that guy looks much, in all the measures of health went along with that. These guys were healthy, younger, etc. Just by getting rid, using gene modification techniques, that worked. And what now, instead of using gene modification, which is harder to do, people are developing what are called senolytics. These are drugs that would specifically kill off the senescent cells. The idea is you're accumulating these senescent cells as you age. You get to this point, you got a lot of them, and they're making you age faster. You use a drug that kills off specifically those cells. It would be like a chemotherapy for cancer, killing off only the cancer cells, but it's killing off only the senescent cells. And guess what? The hope is, if it works like it does in mice, that would de-age us or at least slow down our rate of aging. And another approach to that is to use our immune systems. There are vaccines being developed now that will make our immune systems recognize the senescent cells and get rid of them, just like infection, just like a bacterial cell. A cell coming in from an infection is wiped out, or a virus. We could train the immune system to recognize these senescent cells. This looks like it works in mice. We may be receiving vaccinations against aging in the future. I think it's going to happen. That seems like a pretty easy way to extend your life if it works. And I know I'm hitting you with a lot of science here, so I'll just mention one other thing, and that is we can also use the cells in the immune system. We can modify them in a certain way. There's a very powerful technology now that is really dramatically affecting cancer therapies. You can get your immune system to attack only the cancer cells. And this has been very powerful in cancer biology. And the rates of cancer mortality have dropped a huge amount because of that and other technologies in the last 10 or 15 years. You can use the same strategy to get cells to kill off those senescent cells. They're not cancer cells, but they're the cells that are making you age more. And this works in mice. I won't go through the data. It's another approach to get rid of the senescent cells and make you live longer. Okay, and finally, you might ask, well, how far could this really go? Okay, so now I'm getting into some I'm sticking my neck out here, but I fully believe this as a biologist. I don't think immortality is by any means impossible. I think it will be achievable. And we have to think about the implications of that. And we know that, in fact, because it already happened. We have immortality in us. How many people had kids in this room? Right. You have immortal cells in you because those cells came from a person that, going back, came from their parents all the way back to the first humans and ultimately to the first cell on Earth. And each time those cells are refreshed, okay, they're fresh cells, they've been rejuvenated, and they keep going on forever. So the cells that gave rise to your children just keep going on, and that will go on forever. It's the same cells. Well, it's one cell divides to two cells, 2 to 4, and so forth. But that is, you can trace the lineage, just like you could trace your ancestry, who were my grandparents and so forth. The ancestry of the cells can be traced back forever, and they can be traced ahead forever as long as the planet doesn't blow up. We have immortality within us. We already know that. So that's already achievable. And I think that if we figure out what is true about these, why these don't have the aging stuff that their parents did. There was a woman just this year who gave birth to twins in Uganda. She was 70 years old. 70 years old. She gave twins. The twins were babies. They were 70 years old. They were babies. So we just have to say, okay, what is it about the cells that get rejuvenated, and how can we rejuvenate our own cells? And I think that's coming. It's a big problem, but it's coming. And one other thing about the sort of immortality idea, and this is this idea of escape velocity. So, as you may know, when you send a satellite around the Earth, if you go fast enough, so you're going around and around, but if you get enough power there, the Apollo astronauts and anything that's leaving the planet, if you go fast enough, you'll eventually shoot out, you'll escape the influence of Earth's gravity. That's called escape velocity. And there's this concept of escape velocity in the aging field. So here's the notion. The technology is advancing all the time, getting better and better, all the stuff I talked about. And every time you advance technology, you extend lifespan, right? But if the lifespan extension lasts longer than it takes to get to the next technology and the next one, at some point you reach this critical point where you're always ahead, your own life is ahead of where the next technology will come from. You reach this escape velocity, that could mean that approach would result in immortality. Basically, the technology is always keeping ahead of you. And Aubrey de Grey, who's fairly famous in this field, says the first 1,000-year-old person is probably only 10 years younger than the first 150-year-old person. He's sort of thinking that. Now, I don't believe that. But the notion is there that the technology keeps getting pushed ahead. You just have to wait for the next technological advancement. Okay, I am not going to talk about a lot of social and psychological things because I've really run out of time now. What I will do, I just want to mention, because this is a firm and you guys are all interested in the financial aspects, I want to say a little bit about longevity and its impact on the world financially. So there was a study that came out a couple of years ago by two economists, one from the London School of Economics and one from Oxford University, and this guy is a very famous longevity researcher in the field. And they found in their model that a slowdown in aging that increases life expectancy by 1 year, so whatever the thing was, extend lifespan by 1 year, the impact on the world's economy because of productivity, lower health costs, et cetera, is worth $38 trillion 1 year. That's what they claim. Reminding you that the U.S. GDP is 29 trillion, so more than the GDP of the Earth of the United States. And therefore, if it increases it by 10 years, that would be worth $367 trillion. The total GDP of the world is something like a third of that amount. Point is, this would be enormously stimulatory to economies, right? And then there's all the social issues, and we could talk about that perhaps in the discussion. But this also means that if you're gonna experience this, you got to think about your investment horizon. How will the extension of health span affect financial strategies? And here's a couple articles, J.P. Morgan, et cetera. How long you expect to live? Watch out, it's probably longer than you think. And that is true, I think. And one way to handle that is to reach what I call, this is not common in the field, but what I call financial escape velocity. That is to say, if you do these kind of, you put the numbers and you say, here's how much money I'm putting in, and here's what the the investment rate and the return is going to be. What I always like to try to strive for, it's very hard to achieve, is the point where I've reached basically infinite growth. That is to say, the amount I take out is always less than the gain I get just by investment. And ultimately, so this is, the investments are just increasing. The amount you're taking out is much less. So you've reached escape velocity. You're independently wealthy forever. And that's one way to deal with this. Now, we can talk about that. I'm not an expert at all in this, but we could think about that. And then finally, I'm going to say one more thing about the sort of human aspect of this, the social aspect. If we're going to live to 150, this poses a possibility that I think is really wonderful. And that is, you go to college, for example, you develop a career, you develop your wealth, you're now stabilized, maybe you reach financial escape velocity, and you retire. And then you have kids. Now think about this. I had 3 kids. I didn't get to raise them the way I would have liked to. I didn't get to spend the time I would love to have spent with them because I was building my career up, and it was intense. Science is intense. And there was this constant battle, struggle. It was really miserable. I want to be with my kids, but I get these papers published, or I'm not going to get tenure, or I'm not, whatever, not going to get a grant. Imagine if you separated out this, right? Can you imagine how many good parents there would be on this planet? And then after the kids grow up and leave the home, maybe at age 60 or 70, they leave the home, then you start on your next career, right? I don't think this is a crazy idea. Okay, there are all sorts of societal issues. We can talk about these. I'm really up on the time limit. There are obvious things. Let me just hit on what those are. One is income inequality. Very wealthy people will have access to this first, and those that are not won't, and that's really a very disturbing trend. Then there's the population effect. I'm going to skip all that. But the effect on the world population, that when you have too many people, I have very good answers for both of those things. But let me just sum up what I think is coming. We're going to be able to track aging. We already are. You can already do this. You can pay to have this done. Track the rate of aging and look for interventions in yourself that slow it down. Longevity drugs are being tested. More, clinical trials going on right now. Vaccines are going to be coming, I think. Cellular therapies are going to be coming. They're already using in cancer patients. So now we're going to use them in getting rid of senescent cells. Gene therapy will be coming. This will take longer, but I think ultimately gene therapies may really extend lifespan of life. And all of these are going to extend our period of longevity enormously. And I think it's coming. So I think the other key message I'll leave you with is that we don't have to face the expectation that the arc of our lives will be what we believed in a certain time frame. And I think we won't face that expectation. And the people who are going to be affected the most are the youngest people in this room. And they're the people who come least frequently to my talks on this stuff. But they're the ones that are going to have to deal with it. Okay, that's what I have to say, and I'd be delighted to take up. Michael, do you want to let people who need to go? So if you need to go, please do.
Fine, no worries.
Because we're right at 7 o'clock.
If you want to stay around, we're not, we don't have to kick anybody out for a while. So if you want to stay around, ask some questions, or just hang out, that's fine too. But I think we have our first question in the back.
And I guess if he wants to, I'm going to be around, I have to be out of here by tomorrow morning at 5 a.m. So,
please don't feel obligated to stay. That's all.
It said sleeping increases life in men for 3 years. Are you seeing different from those in 5 years? Are you seeing differences in men and women and the studies that you've been doing?
Yeah, 5 years for men, 2 years for women. I don't know why there's that disparity. Women live longer as it is. There aren't. So there are. One of the things that's different is that hormonal women's hormones can affect longevity. In fact, so there is a contributor there. Potentially, I'm not really strong on these numbers, but delaying menopause may actually extend lifespan in women. Obviously, they're not going to do it in men's. These other things we've talked about, a lot of this hasn't been dissected at that level yet. Most of the studies I've talked about, either the answer isn't known or it affected both sexes even. But I think it's a great question, a major area that needs to be looked at very closely. And as you know about women's healthcare, there's been a big infusion of money. We have a big thing going on my campus about this. One of the members of the Center for Aging and Longevity is looking at the sex difference effects on longevity. Yes.
Have there been any studies about when we have children, how that our life expectancy?
I'm sure there are. I don't have them at the tip of my tongue. But the problem is that people who are older who have children tend to be in a different socioeconomic position than people who have children younger. And it's sort of inversely proportional. So you have to be able to sort out those issues. The life expectancy of the underclass, if you want to call them that, people who are, this is really pretty striking. Let's see, where is the other curve I have? There we go. So this one, the life expectancy across education levels, for example, differs by 16 years from less than high school degrees to advanced degrees. That's one parameter. I have a whole bunch of these things. Race has a huge effect because race is associated with socioeconomic status. Socioeconomic status and the time at which people have children, of course, is affected by that. So it's been hard to dissociate that, and I don't know of a rigorous study that is dissociate the social elements from the actual biological elements. I don't know the answer because of that. It's a complicated from Victoria.
I guess I was thinking of salmon, who apparently there's almost instantly when they born age.
Males, including in humans, it looks like, and certainly in these little worms, but in humans too. What do they call eunuchs? And in the old days, eunuchs were made. The falsetto voice. What are these players called? Castrati singers who a high voice because they were taking care of early poor puberties. You live longer. Sorry, bad news if you didn't do that to you. How's Taylor what's the chance? So I think you're out of luck. Yeah, so that is true. So and that's been shown in a lot of animals. The males that don't reproduce and can't reproduce live longer. Reproduction in female and in these little worms for sure. Reproduction in these little worms speeds up aging for sure. It definitely does that. In humans, I don't want to get into that because it's hard to dissociate. But there's a thought in evolutionary biology that that the selective pressure to keep you alive, the reason that we live as long as we do is kind of to take care of our young, and maybe there's even this grandparent effect. But once you've had your children, it's kind of a signal to your body. You say, okay, now you already produced the next generation. Evolution only really cares about being able to reproduce, right? You reproduce, see you later. Yes.
How much of what you're talking about in terms of longevity and aging and slowing that process is related to telomeres? Because we know that the lengthening of telomeres is protective against aging, and with exercise and sleep, that helps telomeres. So how much of this is related to that telomere length?
Okay, so maybe you're a plant. Do I have that slide in here? But I'll just say it. So telomeres. So she's asking how much of this has to do with telomeres, and I want to show the slide if I can find it. Because do I have it here or do I not have it here? It shows. Well, here we go. Here, this is the relevant slide to that very insightful question, very important question too. So telomeres. So our chromosomes. You think of we have 23 pairs of these things. And at the ends of each chromosome are these things called telomeres. They're specialized endings that allow the chromosome to be maintained. And it was discovered a long time ago that as we age, they get shorter. In cancer cells, they don't get shorter because there's an enzyme that keeps making them longer again. And that's why cancer cells live forever. This enzyme actually was discovered by a UCSP graduate, Carol Dreyer, and she had a Nobel Prize for that. And that discovery was very important, and people jumped all over telomeres. And in fact, it's very clear telomeres are very associated with the aging program. And if you can intervene, make the telomeres stay longer, then that is an important intervention. I left it out because I already had it slammed you with a lot of other stuff. But it turns out this just came out a few months ago, I believe. There is a compound that actually activates the synthesis of fueling, is making them longer again. It actually activates making them longer again. And it decreased senescence of mice. It increased neuron function, cognitive function, neuromuscular function. It works. So these are other potential drugs that act at a different level yet. Telomeres, they would be one of them. There are a lot of different drugs, and that is a really good question, and it is a major avenue to pursue.
I was curious, two things. I was curious, the Ozempic was a GLP-1. That has to be having some effect on longevity.
So I don't know what the clinical studies on aging is for that stuff right now. I don't think it's in clinical studies before the aging. They obviously gone through all sorts of clinical studies for its treatment of obesity for sure. But my guess is it may very well have an impact on aging. There's not really that I got to go look again, but I haven't seen anything that convincingly showed the kind of effects I've seen yet because I haven't been done.
I also want to ask you, rapamycin, we get it to you. I have a friend who's in wellness. I hear it all the time. I hadn't heard about the other taurine. Was it? Is that how you pronounce that?
Yeah, taurine is heard about that. So is that what it brought us? So it's you always make a lot of money off this, by the way.
Are they both going to be readily available in your local?
This is readily available. Rapamycin is by prescription. It's a prescription drug. It's a regulated drug. These are regulated. Supplements are not regulated by the FDA in the same way pharmaceuticals are. They're regulated kind of about the level that food is. So that's a little bit of a problem because, what's the best brand or what's the safest or whatever? It doesn't go through quite the same rigor that drugs do, like rapamycin would be. They're not as very. That's what it talks about. Yeah. So yes, Peter, yes. Peter Attia, by the way, poo-pooed this stuff. He said, he had an article that came out. This is a sort of a very public figure in the domain. He's an MD. And he said, you just urinated it out. And he didn't get any evidence for that. I don't think that's probably true. I have one person a wealthy man who decided to try it on himself. And he took taurine for 3 months. This is one person, totally anecdotal. His taurine levels in his bloodstream, doctor to measure, went up by a factor of 3. It was almost too high. It's not too high, but way up. But I think Attia is probably lower than them. But rapamycin, very promising. It's by prescription. I'm not ready to take it. It is an immune suppressant. It has side effects. I'm not ready to take it. As I get older and as these studies come out, I'm going to certainly look at it seriously.
Take that daily and how much?
I take 1,000 milligrams a day. I'm not recommending it. I'm just telling you what I just keep saying. And it makes you, I don't know, it may be psychosomatic, but it feels slightly pumped, kind of like that.
See, sort of line of thought. What about metformin?
Yes. Metformin is another one, along with rapamycin, that is a repurposed drug. Metformin is used to treat diabetic patients. Maybe used for other. Where was the physician? I think that's about it.
Insulin-resistant PCOS.
Okay. All right. Oh, you're a physician too.
No.
Here's the
Exercise physiology.
Okay. And so metformin it's not in clinical trials. Barzilay, near Barzilay, who is at Albert Einstein here in New York, is really pushing on this stuff. And it's very promising. It's not as promising as rapamycin because it doesn't work on every creature tried. It's a little more mixed as to whether it's going to work. But it definitely deserves clinical trials for sure. Metformin is definitely a good one to go for. I don't think it's in clinical trials yet, but Near's been pushing it for quite a while. I think it'll happen. The trials.
Yes. Could you put one of your first charts which showed the incidence of various diseases? I was wondering what the unit was on the vertical axis.
There was no unit. There's no unit. This is, what can I say? These are rough apart. This is not a true study. There's no dots on it, right? This is not, you would look much messier if you actually had the true roots. This is the overall shape of the curves, but this is sort of stylized, okay?
So normalized occurrence rate is a bit misleading. It's not like a probability of having that disease in 1 year or anything like that.
I think it's, yes, it's normalized. So yeah, obviously these things hit at different rates for sure.
So is it a probability? Is it what?
It is a probability normalized across the whole set. So 2-1, basically. So obviously the incidence of these things is quite different, right? So they've all been scaled to 1. So it's not very meaningful. This was basically just to illustrate the principle.
Yes.
Are there things Is cell therapy and gene therapy going to be able to help people who have family history of heart disease and cancer? And do you have any recommendations for people with family history?
Yes, first of all, be tested, have your genome tested. And be very aware of your family's history because you should be working with your physician, take proactive measures to deal with, obviously, if there's a propensity for cancer, particularly breast cancer in women, first thing you want to be tested for was the BRCA1 gene, which my daughter-in-law she has the mutation, and she had to have a double mastectomy. She had breast cancer at age 30. So you really want to stay on top of that. Heart disease, the practice, basically, I would say be checked much more frequently with a cardiologist for sure. And I think a good physician would recommend you do that. But then I think in the beginning, you were talking about anti-aging.
Cell therapy and gene therapy, that's going to impact.
It will. So there are certainly propensity for cancers for sure. I just mentioned one very striking case. So in fact, my I guess I can say all this in public, but my daughter-in-law I was talking about decided, she and her husband, my son, when they decided to have children, they actually did in vitro fertilization and screened them for the BRCA1 gene, and they took the embryos that didn't have it. But there will be a time when those embryos can be modified, for sure, that's gene therapy, to get rid of that mutation. And mutations that lead to other predispositions, for sure, they're going to be there. But then we get into other kind of scary areas, like, oh, what about intelligence and athleticism and all that stuff? All you really have to work on this in the society. It's kind of recent. But yes, for sure. And cell therapies, cancer, as I already mentioned, very much cell therapies are very effective. So it is not because of any predisposition. It's just that the cancers can be wiped out by the right kind of modification. Some kinds of cancer, the right kind of modification that makes it develop. Okay. Any other questions? Probably wrap up.